Hello everyone. I hope you're doing well with online learning and staying safe and healthy during this time. I will be making these kinds of videos throughout the next few weeks over Chapter 2 and starting into Chapter 3. So you can watch these. There's homework at the end so you can do those problems. And today we're going to break down 2.7 into two parts. First part we're going to deal with linear inequalities. So let's start by indicating the solution of an inequality x is greater than or equal to 4. There are different ways of indicating the solution set of this inequality. The first we're going to look at is by using this number line. So it's x is greater than or equal to 4, so we're going to put a point at 4, and for every point greater than 4, including 4, which means we're going to put an arrow heading off to positive infinity. So every point after 4, including 4, that is included in this solution. The next way is set builder notation. So we're going to write this in set builder notation, which looks like this. This translates to all real numbers of x, right here, such that x is greater than or equal to 4. This is just a different way to describe the solution set for x is greater than or equal to 4. The one we're going to focus on is called interval notation. This is the one we're going to use the majority of the time. It's going to be important, and we say 4 to infinity and notice how I used a bracket before the 4 and a parenthesis after the infinity. This is because when we are including a number, so this is greater than or equal to 4, we use a bracket. When a number is not included, we use a parenthesis. So if it was just x is greater than 4, we wouldn't put them both in parentheses. And whenever we use infinity or negative infinity, we always use parentheses because there's no definite term of infinity. So let's look at some examples. I recommend pausing the video, taking a picture, or writing these down, but it shows us a set indicated in the set builder notation as well as the interval notation. But we're going to mainly focus on the interval notation. So all real numbers between a and b, but not including a or b. So that's when it's less than or greater than, but not equal to. That's when we use parentheses. If we look down here, all numbers greater than a, including a, that is a greater than or equal to, and that's when we use bracket. So we'll practice these in the following examples. Go ahead and take a picture of this, pause it if you need to, write it down. This will be helpful. All right, so let's move on to example 1. We want to use interval notation to indicate all real numbers greater than or equal to -2. The key word here is greater than or equal to. So we know it's x greater than or equal to -2. So using interval notation, we have -2 to infinity, and since it's equal to, we use bracket, and since it's infinity, we'll use a parentheses. In example 2, we want to write the interval expressing all real numbers less than or equal to -1 or greater than or equal to 1. So we have two different intervals here. The first interval is less than or equal to -1. So that means x is less than or equal to -1, or greater than or equal to 1. X is greater than or equal to 1. So we have two different intervals that we want to express as interval notation. The first one, since it's less than or equal to -1, we want to write starting at negative infinity, going all the way to -1, and -1 is included, so we put a bracket. And this one is greater than or equal to 1, so we start at 1 and we go all the way to infinity. But we aren't quite done because we want to join these two intervals. And how we do that is we start with the negative infinity to -1 interval, and we want to put this sign. It looks like a large U that represents union, or an OR, because it's either greater or less than or equal to -1 or greater than or equal to 1. And then we put the other interval. And this is the interval notation. So let's move on to properties of inequalities. The different properties are very similar to the addition, multiplication, subtraction, division properties of any normal equation that we deal with. So the addition property is we add c to both sides. If we want to add c to one side, we have to add it to the other. Multiplication goes the same way. We multiply one side, we also have to multiply the other. But there's one big difference. When we multiply or divide by a negative number, then we must flip the sign right here. So if it was greater than, it then becomes less than. And we're going to look at a few examples of that here shortly. But that's when you multiply or divide by a negative number, you flip the inequality. So let's look at these problems. We want to illustrate the addition property for inequalities by solving each of the following. We want to solve this, which means we want to get x by itself, all the numbers on the other side. So we add 15 to both sides, like we're used to. And that gives us x is less than 19. And if we want to write this in interval notation, we would go negative infinity to 19. Okay, and that's it. All we're doing is adding 15, because it's a negative 15, to both sides and solving for x. So on these next two, go ahead and pause the video, work on them, and come back and I'll show you the answers. So for b, we just want to add 1 to both sides. Right? We're just getting x by itself, so x is then less than or equal to 7, or 7 is greater than or equal to x. And for part C, we subtract 7, not add, to both sides, and we get x is greater than 2. So very similarly to all the other equations we do, instead of the equal sign, it's either less than or greater than. And that's basically it. But this is where it changes a little bit when we demonstrate the multiplication property. So for this one, we have 3x is less than 6. What we want to do, well, we want to divide by 3 to get x by itself. But this is positive 3, so we don't have to change the sign or change the inequality. So we have x is then less than 2. Now in part B, I'll show you. In part B, we are going to add 1 to both sides to get the x by itself. So then we have negative 2x is greater than or equal to 6. So to get x by itself, we want to divide by negative 2. And this is when we want to flip the inequality. So it becomes x is less than or equal to negative 3. So this change right here, that's the tricky part. That's the only difference when we're solving inequalities. So in part C, go ahead and pause the video, try this one, and come back and we'll see the solution. So we want to subtract 5 on both sides. That gives us negative x is greater than 5, but that's a negative x. So we want to divide by negative 1, or multiply by negative 1, whichever you feel. And that makes us flip that inequality, so it's then x is less than negative 5. Alright? And that's the key difference. When you divide or multiply by negative, you want to flip that inequality. Alright, so now we're solving inequalities in one variable. We have 2 more examples, and then I'll give you the homework. So let's solve this inequality. 13 minus 7x is greater than or equal to 10x minus 4. So just like solving any regular equation, we want to get x on one side, the numbers on the other, and then solve for x. So we'll go ahead and add 7x to both sides, and that'll get us 13 is greater than or equal to 17x minus 4. So the x isn't quite isolated yet, so we need to add 4 to both sides. And that'll get us 17 is greater than or equal to 17x. And one final step when we're solving for x, we want to divide any coefficients. So 17 divided by 17, and that is 1, and that's greater than or equal to x. Alright, so that's solving inequalities in one variable. We'll go ahead and look at this one when we're dealing with fractions. So fractions can get a little messy, but trust me, they aren't that bad. So similarly, we want to get all the x's to one side. So I suggest subtracting 2/3 x to both sides. And 3/4 and 2/3, they don't have common denominators, so we have to keep them separate right now. And that is greater than or equal to negative 5/8. So what we want to do is get these common denominators, get these to be common denominators, and the common denominator of 3 and 4 would be 12. So we multiply this one by 4 over 4, multiply this one by 3 over 3. And that gets us negative 8 over 12x minus 9 over 12x is greater than or equal to negative 5/8. Now we want to simplify. So negative 8 minus negative 9, that would be, let's see, negative 17 over 12x is greater than or equal to negative 5 over 8. And the goal is to get x by itself. So we want to multiply each side by 12 and divide by negative 17. So x is less than or equal to 15 over 34 because we want to flip that sign. So then our interval notation would be starting at negative infinity, going all the way up to 34, 15 over 34, and we want that bracket in there as well. So that is the answer. Always try to put it into interval notation, get that practice in, and here is the homework. So starting next week, I will be posting 1 or 2 videos each week, so keep checking this page. I'll have Mr. Bradick send out the link so you guys can know. And keep doing this homework, and we'll send updates on any quizzes or tests or test reviews. Alright, so have a good weekend, stay safe, stay healthy, and see ya.